All right, guys, we're going to talk about the Earth's resources. Basically, essentially, what we're talking about in this section is mining and the implications that that's going to have for us environmentally and some human impacts as well, and a little bit into the different types of mining. Now, the reason that this really matters for us, and the reason this is kind of a big issue for us environmentally and socially, is because we don't have equal mineral resources distributed all around the map. I like to think of this as I like to play a game called Civilization. And one of the things in Civilization, I mean, the point is you're trying to build up a civilization in the world. And so one of the cool things when the game starts is sort of seeds and puts different minerals and different resources all over the map. And so, of course, what you have as a civilization sort of determines the outcome that, some of the outcome of the game. So if you have horses, maybe you're going to go straight for horsemen and things like that. If you have iron and copper, maybe you build a lot of military units. If you have fish off the shore, you build a lot more naval units. And I know that's a weird sort of game example, but I mean, that same thing is true for us overall in the world, is that we have different amounts of resources in different places, and that has drastic effects on the geopolitical situations. There's some pretty drastic effects on environmental issues as well, but it really has some really high implication in social areas. A good example is like, if you look at this map actually is of oil concentrations, of oil deposits and reserves around the world. And of course, you see that there are some areas with almost no oil, like Australia has basically none. A fairly good amount in North America, and then you see this gigantic concentration here in the Middle East. That obviously has some pretty important social implications and political implications, because that's why the United States tends to be allies with those countries, even though we might not necessarily agree with all their governmental and social policies, because they have resources that we require. And really, the resources that we have on the Earth, they're set at the time that the Earth was formed. And so, what was there then is what we have now, and what we're essentially trying to pull out of the Earth. And so the abundance in the Earth, and this is the crustal abundance, this isn't the atmosphere, this is just the crust, is that the most abundant element that we have in the Earth is oxygen. Silicon also pretty common. Those two things together make up sand. Okay, so that kind of makes pretty good sense. Aluminum, actually the third most present element in the Earth's crust. There's a ton of aluminum out there. One of the problems with aluminum, though, is that even though we can mine it, it's actually pretty hard to extract it. It takes an enormous amount of electricity to do that. Iron, magnesium, calcium, and then everything else is about 5.6%. So you can see that the vast majority is just a couple of elements. And so that means that things like gold or silver or copper are all in this other 5.6%. And so there's not really a lot of them there. And when we get to like rare earth metals and stuff that have become increasingly important to us in the electronics industry, they're in even smaller percentages. And so therefore they're in pretty limited abundance. So we get these things from ores. Ores are accumulations of minerals. We tend to think of it as metals, but it doesn't have to be. I mean, we mine things like phosphates, we mine things like salt, and all those things as well. And usually they don't come in pure forms. Like we always think of mining as like, okay, there's a vein of coal or there's a vein of gold there, and that is true in cases like that. But a lot of times they're bound up with other things. So like, for instance, this is copper ore. Sorry for the train, guys. And this is bauxite, which is aluminum ore. And you can see that neither one of them really looks like, this looks somewhat similar to copper if you think about copper being oxidized, like the Statue of Liberty. But this doesn't really look anything like aluminum. And of course, that's the trick, is not only do we have to mine it, but then we have to process it, and that sometimes takes a lot of energy as well. So the reserves of something are the publicly known estimate of how much we think is available at this point. Now that can change. In fact, one of the things that I think about is if we look back at this map that we had here at the beginning of the oil reserves, when I was, and this is going to sound incredibly nerdy, but when I was a child, one of my favorite books, I had this book called Earth. It was basically a big atlas, and it had all the countries, and it had all of these, like where everything was found, gold and diamonds and copper ore and oil and stuff like this, and it had reserves. And what was funny, and this is, I'm talking, I was a child looking at this stuff in the 1980s, and so 30 years later, those estimates were obviously way off. We were predicted to sort of not necessarily run out of oil, but for oil supplies to be running really low. And that's not really the case. And part of that is because as we advance in technology, to some degree, these estimates will change because we can find deposits that we couldn't find before. Now, of course, we're still talking about finite resources here, okay? So there's only so much of it regardless. And so at some point, it's likely that these things are going to run out. In fact, the current estimates are for a lot of things that will run out, and the U.S. has already run out of a lot of things like nickel and cobalt and stuff like that. And so we have to import them from other countries. And worldwide, if we keep up the consumption level that we're at now, there's a lot of things that we're predicted to run out of in the next 30 to 40 years. Now, that doesn't necessarily mean that that's going to be the case. I mean, we could find new resources. But again, what we'll see here in this unit is that it gets harder and harder to extract those resources as we go on. So how do we get them out? We get them out mostly from mining. And there are two main types of mining, surface and subsurface, and that kind of makes sense, on top of the surface or going just a little ways into the surface, and then basically subsurface, which would be underground mining that we often think of. So different types of mining. The first type here is strip mining, and it is exactly what it sounds like. You're basically mining in strips. They're taking sort of these horizontal swaths out of the land with big machinery. They're pulling it up. They're moving the soil and the rock. The ore is coming up, and then they're going to go through and harvest out the ore. Now, one of the things that you may not think about in mining is that a lot of times, and almost all the time, when you're mining something, you're getting a very small percentage of the stuff that you dig up is actually the ore that you need. So you might mine 1,000 tons of rock to get 1 ton of ore that has your copper in it, and then you have to refine that down, and maybe you get half a ton of copper out of that. So you've got to tear up an immense amount of area to get really sort of small amounts of stuff. And so what that means is there's a lot of stuff left over. We call that stuff that's left over. Sometimes it's called mining deposits. It's called tailings a lot of times. And those tailings, what happens to them is also pretty environmentally significant. Are they put back where they were mined from? Are they dumped in a valley next door? Are they just heaped up in big piles? That has some pretty immense environmental impacts as well. One of the most, it seems like it's often the most destructive, and really I don't know that it's the most destructive, but it's sort of the most obvious and sort of gaping sort of thing, is open pit mining. Now these pits, and they're just like what it looks like here. It's basically just a giant pit in the ground. How big sort of depends. I mean, you can think of like a small quarry that you might find locally that's maybe a couple hundred meters each way, or you can have something that's like, I think the biggest one is out in Utah, and it's something like 4.4 kilometers wide, and it's like, I want to say a mile deep or a kilometer deep. So really giant open, and from the perspective of like looking at the environment, that's just sort of a big gaping hole, and of course any habitat that was there is completely demolished at that point. Now it doesn't necessarily mean that it destroyed valuable habitats. That's what we have to consider and sort of put in our instrumental and intrinsic values to decide that. But big, massive pits. And again, they don't have to be huge. It could be like a quarry where it's a pit that's sort of in a much smaller area. Open pit mining tends to get used, I didn't really mention this, but strip mining tends to get used when everything is laying pretty much right on the surface and running parallel to the earth. So the earth is here and the stuff is running underneath it, just a little ways under the soil and rock. Pit mining, the stuff is down a little bit deeper, and so they've got to really dig a lot deeper to get to it. Copper mining usually is a pretty good example of this. To come to something that's pretty controversial in our area of the country is mountaintop mining. And in mountaintop removal mining, it's just what it sounds like. Basically, they blow up the top of the mountain so that they can get to the stuff underneath. Typically coal is why we do this. And then what happens to the tailings then is sort of what becomes the big issue, because there are benefits to mountaintop removal mining. It's much less dangerous than subsurface mining, the mining underground for coal. But of course, what happens to all of those tailings? I mean, if you blew off the top of the mountain, where did you put the material that was the top of the mountain? And usually what they do is they just fill in a valley next to it. Now, of course, that's going to block up or dam up any rivers. It's obviously going to destroy whatever habitat was there. And so this sort of depends. I mean, there are companies now that are really working really hard to, once they do that, to fill back in the top of the mountain, and then to try to restore the valleys wherever that they stored things while the mining operations were going on. And again, it's a cost-benefit thing. I mean, if it saves human lives, is it worth risking habitats? Okay, and so, I mean, again, that's where some of our ethical considerations come into play. There's also placer mining. Now, this doesn't happen an immense amount in a lot of places in the United States anymore. Definitely happens in a lot of third world countries, and it does happen to some degree. And basically, it means that there are river sediments, and that you're trying to pull out the precious stones or metals from that. And the image that I always get in my head for placer mining, even though this isn't entirely accurate, is of, miners in the Old West, the 49ers that sort of had their little trays, or like you might do at Dollywood, and try to sift out your stones or your gold. And that's essentially what placer mining is. Now, there's more sophisticated methods to do it now. And in fact, they use a lot of chemicals to do it now, not just the water. So they try to leach out some of the minerals by using chemicals and not just by a flow of water like they might have done back in the 1800s. And then, of course, we have subsurface mines. So this other four categories were all surface mining, basically. And subsurface is just what it sounds like. It's where we have to dig deep underground to reach the resources. Usually if something's more than 100 meters below the surface, then we're probably going to have to dig some sort of tunnels to get down to it. Now, of course, this is pretty common for coal. It's also very common for things like salt. And these mines can get incredibly deep. A lot of them are 2 miles deep. A lot of times they go under rivers, they go under lakes. I remember watching some TV shows on some of these mines, and I know one of them they were going, it was near Detroit, a salt mine, and they were going under Lake Michigan, which to me just seemed like the mental image in my mind was just horrifying to think. Not only do you have all that rock above you, but you've obviously got a giant lake above you as well. Of course, subsurface mining, it tends to be much more dangerous than surface mining, because if something goes wrong, you're essentially trapped most of the time. And usually trapped in a pretty hazardous environment. So something like a coal mine has a lot of gases and stuff like that in there that are very dangerous if the proper safety measures aren't taken, and really are somewhat dangerous even if the proper safety measures are taken. So what kind of environmental impacts does all this stuff have? Well, obviously the mining itself. So I didn't put this on the slide, but obviously the mining itself has some pretty big environmental impacts. If you're ripping a giant hole in the ground, that's going to drastically affect the habitat. If you blow up a mountaintop and fill in the valley next to it, you've destroyed the mountaintop habitat and probably the valley and the river next to it. So the mining itself has impacts, but associated with that as well, you've got to build all these roads to get to the mines typically. That's going to lead to a lot of soil erosion. Building a road through a habitat splits the habitat, and a lot of times the animals can't cross, and so that disrupts things a lot of times. To build the road, you may have had to dam rivers or at least alter the course of these waterways. The tailings very often are going to contaminate things. So if the tailings are just dumped, then a lot of what was formerly in the ground is then going to be able to leach into the water or contaminate the land. Of course, if they are just filling in valleys or filling in areas, that's going to block or change the flow of rivers as well, which has habitat effects, but also has effects on our water and soil quality as well. And some more environmental impacts, but human impacts as well. Of course, there's immense health risks for the miners, particularly if it's subsurface mining. The mining operations, very often they use a lot of water to rinse things out and to keep dust down a lot of times. But the water that runs off from that usually hits the metals and becomes very acidified. Okay, and so that's going to lead to a lot of pH, a lot lower pH, a lot more acidic pH in the water and in the soil, obviously, that water is going to flow into. And to be honest, a lot of the chemicals that are used in mining are very toxic. One of the prime examples for me is one of the ways that they get gold out when it's not in a vein, when it's actually in ore and stuff, is that they treat it with cyanide, which obviously is pretty poisonous, and then that can leach into water and soil supplies. So the overall thing here, and remember our main theme all year is sustainability, and so what gets harder and harder is that as we use up these resources, we've gotten to all of the easy places to get the resources, and so it becomes harder and harder. Now our technology increases so that we can do that, but it becomes more costly both in monetary terms and oftentimes in environmental terms as well. So like for instance, we've gotten a lot of the easy to get oil out, and so then we go to places like the Gulf of Mexico and try to mine at the bottom of the Gulf, which has obviously a lot of dangers, as we saw a couple of years ago when the Deepwater Horizon blew up, and we had this 60-day long oil leak into the Gulf. So it gets harder and harder as time goes on. And so we just want to sort of keep that in the back of your mind. Obviously, mining is important. We need these resources, and it's economically important. But again, there are environmental costs to these things, and we have to sort of sum total the sustainability